Multiplying numbers in scientific notation can actually be faster than multiplying the same numbers written the usual way. So let's look at this product. Here we have 2 times a number written in scientific notation. Remember, a number written in scientific notation has 2 factors. The first is a number greater than or equal to 1 and less than 10. The second factor is a power of 10. They are separated by a multiplication symbol. You might think that the number on the outside of the parentheses should be distributed. But remember, we only distribute over addition or subtraction. And this is multiplication. This is the same as 2 times 4 times 10 to the 9th power, or 8 times 10 to the 9th power. We can multiply the 2 and the 4, and look, our answer is in scientific notation. So this is our final answer. Let's try another one. This time we're multiplying 0.08 and 5 times 10 to the power of negative 12. And since this is all multiplication, we don't need the parentheses. Let's multiply 0.08 and 5. When we multiply 0.08 and 5, we get 0.4 times 10 to the negative 12th power. But this number is not in scientific notation. Remember, in scientific notation, the first factor is greater than or equal to 1 and less than 10. But 0.4 is less than 1. So what do? Let's move the decimal place 1 to the right to make this 4 instead of 0.4. Since we made the first factor larger by moving the decimal point 1 place to the right, we need to make the exponent of our power 1 smaller so that our number doesn't change. So our answer is 4 times 10 to the power of negative 13. Let's look at this product. 2 times 10 to the power of 3 times 4 times 10 to the power of 5. Just like last time, the parentheses don't matter since everything is just being multiplied together. So let's drop those. And now we can use the commutative property to reorder the factors. We know that 2 times 4 is 8, but how do we multiply the 10 to the 3rd power and the 10 to the 5th power? Remember, when you multiply powers with the same base, you just add the exponents together. So 10 to the power of 3 times 10 to the power of 5 is 10 to the power of 3 plus 5, which is just 10 to the power of 8. So 2 times 10 to the power of 3 times 4 times 10 to the power of 5 is equal to 8 times 10 to the power of 8. Here we have 3 times 10 to the power of negative 2 and 8 times 10 to the power of 5. The parentheses don't matter since everything is just being multiplied together. So let's drop that and use the commutative property to reorder the factors. 3 times 8 is 24, and 10 to the power of negative 2 times 10 to the power of 5 is the same as 10 to the power of negative 2 plus 5. This gives us 24 times 10 to the power of 3. This number is not in scientific notation because 24 is greater than 10. So let's change 24 to 2.4, and because we moved the decimal point 1 place to the left, which made the first factor smaller, we need to make the exponent of our power 1 larger. Our final answer is 2.4 times 10 to the power of 4. Let's do one more. Here we have 2.3 times 10 to the power of negative 7 times 6.1 times 10 to the power of negative 2. Let's drop the parentheses and use the commutative property. 2.3 times 6.1 is 14.03. And 10 to the power of negative 7 times 10 to the power of negative 2 is 10 to the power of negative 7 plus negative 2, which is 10 to the power of negative 9. 14.03 times 10 to the power of negative 9 is not in scientific notation because 14 is greater than 10. So let's change 14.03 to 1.403. Because we moved the decimal place 1 place to the left, we need to make the exponent of our power 1 larger. Our final answer is 1.403 times 10 to the power of negative 8.